All right, eighth graders, back again, the digital classroom. Today we're talking distance formula, which is another application to the Pythagorean theorem. A little bit more algebra focused because we're kind of taking context out of it and focusing just on distance between points on a coordinate grid. And, again, keyword here being distance, kind of similar to absolute value. Distance will always be a positive number. I can never be a negative distance away from something. It's just a matter of direction. So what this formula is used for is to find the distance between points on a coordinate grid, such as this. And the distance formula really is very directly connected with Pythagorean theorem, and we're going to kind of explore how to find that distance today. Again, though, if we've got 2 points, let's call this point A and this point B, there's exactly one distance in units between those 2 points, and that's what we're looking to find. And now, if you think about it, you can see a little right triangle here. The base of that right triangle is basically how far apart the x's are, all right? How far apart your x values are in the 2 coordinates. The height of the triangle is how far apart the y's are. Okay, if the y values are 2 and 3, you know that those are just 1 unit apart. So that would be your height of your triangle. And actually, this understanding goes directly into the formula itself. So this is something you guys should be writing down. First thing, distance is equal to, it's a big long formula, so just be careful here. Square root of x2 minus x1 to the second power plus y2 minus y1 to the second power. This will tell us distance between points. Now, what you should start to be able to see within this is kind of the Pythagorean theorem. We've got a value that's squared plus a value that's squared, and then at the end, you take the square root of everything. Well, it's very similar to Pythagorean's theorem, and we'll show exactly what that might look like with a couple examples today. All right, so let's hop into it. First thing, find the distance between the coordinates -3, 5, and 4, 10. So you guys should add this to your notebooks. All right, this is example problem 1. Now I'm going to show you on a graph actually what this might look like so that you can really get a firm understanding of what the question is asking. -3, 5 on a coordinate grid is 3 units to the left and then 5 units up. Okay, so it's about right here, and we're just going to label it point A. We want to find the distance between point A, which is -3, 5, and then point B, which is at 4, 10. 4, 10 is 4 units to the right and 10 units up. So let's just estimate it here. Okay, this is our 4, 10. We'll call this B, and we'll also label it 4, 10, -3, 5. So again, like I said, we're looking for how far apart are these 2 points in units. Well, if we're looking for this, okay, kind of a bad line, but if we're looking for that distance, one way of finding that is to kind of envision it as a right triangle. We could find the base of the right triangle and the height of the right triangle simply by looking at our x values and our y values, okay? Well, in this case, y values 10 and 5, those are 5 units apart. 5 is going to go in this spot. The x values 4 and -3, well, those are 7 units apart. 7 will then go in this spot. So in essence, what we're looking for is the hypotenuse of this triangle. We're looking for C to represent distance. Now, this is only one way to do it. We could write this out and go 5 squared, 7 squared equals C squared and solve the problem. Okay, that's one way to do it. The other way to do it is to actually plug numbers directly into this formula and then kind of work from there. You should get the same result. Okay, so we're going to try and use the formula correctly. So first thing we're going to do, or first thing I'm going to do, is label values. So this is going to be x1, y1, x2, y2. After that, I'm going to plug into the formula. I like to write the formula down. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and then sub values in. So we've got distance equal to the square root of, Well, let's do x2 minus x1. So that's 4 minus a negative 3 to the second power plus y2 minus y1, 10 minus 5 to the second power. Now we do some math. D is equal to the square root of, let's see, 4 minus negative 3 minus a negative is equal to adding a positive. So that's 7 to the second power. 10 minus 5 is 5 to the second power. And notice how we ended up with 7 and 5. Well, that was our base and our height, right? So you should end up with that. The formula is meant to kind of give you the base and the height without having to draw the picture. So now we just do the math with it. Square root of, let's see, 49 plus 25 will get us our answer. That's the square root of, let's see, 74. Okay, the square root of 74 would represent that distance. Oops, got to scroll up for you. Sorry about that, guys. Square root of 74, which when I calculate that, I put it into my calculator. Square root of 74 is equal to 8.6. So that would be our distance. Distance is 8.6 units apart. So it's a pretty intuitive formula. Again, once you get comfortable using it, the big thing that you guys want to watch out for is your subtraction. Make sure that you're subtracting correct. The other thing is order of operations. Make sure that you're raising your numbers to the power first before you add the numbers together. And then just kind of take it from there and you should be able to get it. Example 2, and we'll graph this one as well just to kind of show where these coordinates are, but 4, negative 7, and 5, 1. So if I was to plot those on a graph, 4, negative 7, and this is going to be down in my bottom right quadrant. So 4, negative 7, 4, and then negative 7. Let's just put it here. And then 5, 1. So the right 5 and up 1 would be about here. All right. And once again, we're looking for the distance between the two in a straight line. So how far apart is this from this, basically? Okay. It's not as simple as just counting boxes or counting units, right? Because of the fact that this is going in a diagonal manner, we know that it's not just a matter of counting like, 1, 2, 3, 4, or whatever. We have to use the formula. So let's get to it. Formula is going to again be written out. D square root of x2 minus x1 to the second plus y2 minus y1 to the second power. Plugging in some numbers, so let's label. We've got x1, y1, x2, y2, and we just got to plug the numbers in. So distance is equal to the second x minus the first x. Well, 5 minus 4 would go in that spot. 5 minus 4 squared. Plus second y minus first y. Second y is 1. First y is negative 7. So we go 1 minus a negative 7. And it is important to include the negative. All right, if you just do 1 minus 7, you get the problem wrong. And again, we're squaring that value. Do some math. Again, we got a big old square root symbol. You guys will get tired of drawing that. But 5 minus 4 is 1 squared. 1 minus negative 7 is equivalent to 1 plus a positive 7. So that will get us 8 squared. Do some math again. 1 squared, easy enough. That's just 1. So you got 1 plus 8 squared, which is 64. 1 plus 64 is 65. Our distance is going to be the square root of 65, which should be just a little bit higher than 8. And I'll just be thorough with that. 65 square root is 8.06. So the distance is 8.06 units. I would say rounding to the nearest tenth is fine. So 8.1 would be an acceptable answer there. All right, so just a little bit on the distance formula. We're going through 2 examples. You guys get an opportunity to practice it. But it is just kind of a branch off of the Pythagorean theorem. And if you guys really want to, this is just an alternative, right? Think to yourselves, how far apart are the x's? 4 to 5, that's going to be the base of your triangle. 4 to 5 is a base of 1, okay? Height of the triangle, how far apart is -7 to 1? How many units apart are those? That'll be the height of the triangle. So this is a pretty skinny right triangle with a base of 1 and a height of how far -7 is from 1, which would be 8. And at that point, you're just using Pythagorean theorem. Okay, 64, 1 is equal to c to the second. That's 65 equals c to the second power. To solve it, take the square root of each side. We get 8.06 again. Okay, so that is another option. And we could have done that with this one. In fact, we started it, but we didn't finish it. So you can either use that right triangle way of doing things, or you can use the formula. Either way should get you the correct distance. All right, guys, hopefully the video is helpful. We'll talk to you soon.